Hi, I'm Justin Kirk, and in this video, I'm going to be showing you how to make this skeleton AI. So I found a lot of videos online for how to make enemies, and the majority of the videos that I found, honestly, they're using a state machine. They walk around, and they chase the player when the player gets close enough. I did make a video on how to make one of those as well. My video is obviously better than the ones that are on here, so if you want, you can check that out. I'll probably link that in the description. I'm also going to be posting this skeleton completely for free, so if you want to use this skeleton in your game, you don't need to like tribute it or license or whatever. You can just use it if you want to. But yeah, let's get started. Okay, so the first thing you need to do is download the model for the skeleton. Like I said, I'm gonna be posting that in the description, so you'll have to go to the link and just download it. And when you download it, you should get a file that looks like this. There's two of them. There's the bone, which is what he's throwing, and then there's the skeleton. So just click on both of them, and you can just drag them into a folder in your Unity at the very bottom here. After you've dragged it into here, you can drag the skeleton into the scene. I'm gonna make my skeleton bigger because my scale is really large, and you can see that my skeleton looks really dinky. You probably won't need to do this because your skeleton is probably gonna be full size by default because most people use a normal size scale, but you know, I'm kind of dumb. So looks like 9 is way too big, maybe 5. Perfect. Okay. So the next thing is that the skeleton is really gray looking. It's kind of like a boring color for a skeleton. That's not the color that we want him to end up. So if we just right click at the bottom here, we can create a material and just call this skeleton material. And then we want to create a shader for this as well. So create a shader. Here it is. Skeleton shader tutorial. And then in your skeleton material, you can go ahead and set the shader to be the skeleton shader that you just made. And then we need to edit the shader. So you could just drag actually the skeleton material right onto the skeleton. And then you can just actually right click the skeleton on the left, click prefab and unpack completely. And then let me just make sure that the material got applied. Hang on. Skeleton person, skeleton material. Okay. So if you double click on the shader, it should open up something that looks like this. So let me just save this, and I'm just going to close the other one that I have because I already did this, obviously. So we want to have a color, so click plus on the left here and go to color, and we'll just call the skeleton color, and we could drag that in here. And then we just want to have a Fresnel effect, and we want to actually be able to control the Fresnel power. And yeah, so then we'll drag the Fresnel power here, drag this into the power slot, and then we will multiply these two together like that. And then this can go to the base color. So let's save this and go back into the scene. And then now our skeleton's black, so we just need to go back to our material, change this to white, and then we just want to make this I can't remember if I just made this negative. Like initially, I don't even know if I need Fresnel. I think I just made it, the other one glowing. I'm not sure. But anyway, yeah, you can play with this. So then the next thing we need to do is make eyes. My skeleton model doesn't actually have eyes, so I created the eyes manually. So to do this, just add a sphere into your eyes. So if you go to the armature, find the head bone, and just right click and add a sphere. And then we just need to put them into the eye socket. The ice locket. Oh my god. Okay, sorry. Yeah. Oops. Okay, so find a spot that you like for your eye, and then if you press Control C and Control V on the sphere, it will just put another one. And you could just drag it over like that. And then you need to right click at the bottom and create a new material called skeleton eye material. Like that. And you can make this the same shader, so just use a skeleton shader again, because I really like the Fresnel effect. Oh, sorry, this is my actual skeleton shader. Let me just do this one. And we can drag this material onto the eye. You could have done this before you copied it, maybe that would have been better. And I think that I made the eyes white on my other one. I can't remember. Let me just see. So, Fresnel makes them blacker, and then they kind of have like this white glow around the edges. That's kind of cool. Okay, and then for the actual skeleton material, I'm pretty sure that I made this negative, and then I turned this to like gray, but I made this more negative. I can't remember. Okay, so that's looking pretty cool. So then we need to drag our bone into the scene. So you can just drag this directly under the player's left arm. Sorry, not the player, the skeleton. So when you drag this here, it kind of... Okay, actually don't do that. So delete the bone, just put it into the main scene because we want to reorient this in world space because it's a lot easier. So make this 5 by 5 by 5 because that's the size that we made the skeleton. And then we can just get rid of this rotation and then rotate it 90 on the y-axis. And then I think he throws the bone with his left arm because that's the way that I made the animation. So you just got to put the bone into his hand. We'll be spawning another bone. So when he throws the bone, it's a completely different bone that gets thrown. It's not this one. And we just want to actually do -90 for this. And because the bone looks cooler like this. Great. And then we also want to put this skeleton material onto the bone. So it should match the skeleton. Like he's throwing his bone at like, I don't know. I was considering when I made this to throw his like actual arm and have it like respond, but it was too much work and I was getting bored of this. I made another sculpt that I'm waiting to play with. Like it's like this cool, it kind of looks like the monster from Doom, the Keiko Demon or whatever. And I'm kind of excited to mess around with that. So I just wanted to finish this and get it over with. But this is like one of the core monsters in a game like this. You need a monster like this to make it cool. So anyway, so this is looking pretty good. This video is mostly just going to be about the scripting of this anyway. So when you've imported the skeleton, you actually need to go into the rig and create an avatar for the model. So at the bottom here, if you don't see the skeleton, there's like a little draggy bar at the thing. Like if you don't see the drop down, you probably have this view. If you just drag this bar to the left, you'll get this view instead. Just click the drop down for the skeleton and then you can, just click on the skeleton itself and go to the rig and create from this model and click apply. Then also go to the animation tab and click on walking. And this needs to be looping. So choose loop time here and press apply. And then I think that's it for setting him up. Oh no, we got to do more. Okay, so we need to add a bunch of components to this. So the skeleton is looking the wrong direction. His face is in the wrong direction. I exported it wrong, and I don't know if I saved it in Blender, so there's no way to really go back and re-export it. So we need to create an empty object, and we're just going to call the skeleton container. That's why my other one was in a skeleton container. So if you ever have an object where the front is the wrong direction, what you have to do is create a container for the object, and then you can set the direction, like the rotation of the object here. Oh, we got to add the bone to his hand first. So we set up the bone in the world space, but now that we have it in the spot that we want, we're just going to drag it into the arm. So it should go right here. And now when we rotate the skeleton, it should be fine. I'm not sure if it's 90 or -90, but he's not going to be facing straight unless you put him into a container, because this changes like his front, I guess, like his forward. But yeah, anyway, so we need to add something. So go ahead and add a rigid body. And we just want to freeze all the rotations and shit for this. All this stuff needs to be frozen, and we don't need to use gravity. He's always going to be at 0y. And then we need to add a box collider, or you could add, technically you could add a mesh collider, but I don't really believe in mesh colliders. Anyway, so we'll just do 0. Oh shit. Okay, so we just need to put the box collider around the actual skeleton. The skeleton container should be... Okay, so the skeleton container should be 0, 0, 0, and then the skeleton should be... No. The skeleton should be 0, 0, 0 inside of the container. That's the problem. So now he's floating, so then we need to put this at 0. Okay, cool. Now if we click on the box collider, it's in the middle, so we just need to make this in the middle of him. So if you put this on the skeleton itself, it will automatically put it in a good spot, but... Anyway, let's just maybe 15y. And again, your scale is probably going to be significantly less than mine because my game scale is just completely oversized for no reason. When I started making this game, so a little bit of background about myself. I'm a professional C# developer. That's what I do for a job. I just started doing Unity development, making this game at the beginning of the year, so about 7 months ago. So I'm not really a professional Unity developer. I do professional C# for like my work, so that's why I was able to get into this so fast. But when I started making the game, I had never made a game before, so that's why I have the wrong scale. My scale is massive. I didn't know that when I first started, so I just watched a bunch of Brackeys tutorial videos and just kind of learned everything I know. But anyway, so this is looking pretty good for the box collider. Let's just bring this up a little bit. And so then the next thing we need is a nav mesh agent. The nav mesh agent has to be placed on a nav mesh surface, and that is an external thing. So if you don't have that in your game, just Google it. You're going to have to add a nav mesh surface. So when you do that, it's just a C# script that kind of looks like this. And it's pretty important that if you don't have this, I think it will still work, but it's way better if you have a nav mesh surface, and then you have to bake it as well. It's important you put your skeleton on a plane, okay? Because part of the script that we're going to do is like the skeleton is going to cast a ray at the ground, and when it hits it, it's going to detect the plane, and it's going to get the dimensions of the plane using that. If you're not using a flat surface, this is not going to work. This is only really for flat surface like planes, or for right now. I might add something for that at the end if I have time, but yeah, this is only really for flat planes. So anyway, so add a nav mesh agent, and then we can set these settings later, but for me, my speed needs to be really, really fast, and then 200, and then 300, 500. Turn off auto braking. Yeah, I'll probably mess with these settings later. Mine, again, it needs to be really high because my scale, but yours you could probably get away with a lower number. Okay, so now we need to put the skeleton into the enemy layer, and you could change the children as well for it. And then we want to right click in the bottom and create a C# script. We're going to call this skeleton script tutorial. Okay, and then after you're done that, you could go ahead and drag the script onto your skeleton. Mine always puts 2 for some reason. I'm not sure why it does that, so let me just remove that. And then you could double click the strip to open it. So after you've opened this, in my other script, I imported from enemy. I have an abstract class. I've made a video on how to make an abstract class. I'm not going to be doing that in this video because it's too confusing, and the video will literally take hours if I do that. But there's a way of reusing the same code for all of your enemies so that you don't have to rewrite code for your enemies. So that's in a different video that I already made. If you look through my videos, just look for the word abstract and you should be able to find it. But anyway, so you could delete the methods that are already here, and you could just put in fixed update. But anyway, so we need a boolean called found the plane. So like I said, the first thing we want to do is try to find the plane that the skeleton is standing on so we can get the dimensions of the plane. So if we haven't found the plane yet, we want to do this. You can only do the raycast in the update method. If you put it in the start method, it won't work because the actual game objects don't get generated until after the start method. Just the way that it works, if you try to put a raycast into the start method, it won't work. So we're just doing it like this. So after it's found the plane, like we'll keep trying to find the plane until it finds it, and then when it finds it, then we'll start doing the other script. So we need a raycast hit. We need a layer mask as well. Okay, so what this does is this means every layer except for the 8th layer. Because we made our skeleton an enemy, so we put him on the enemy layer. My enemy layer is layer 8. Make sure you make this the same layer that you're putting your enemy on. So if your enemy like layer is a different layer than this, if you don't have the enemy layer, like if that's not there, you can press add layer and make an enemy layer, but just make sure it's the same number that you're using for your layer, because that's the entire point of it, I guess. So we're creating a layer mask. This will do everything except for 8, so that's what this essentially means. And then we want to do a raycast. Okay, so what we're doing is we're casting a ray from 50 above. So this is X, Y, Z, right? From 50 above the player, and we're going negative transform up. So we're going below the player, and we're outputting whatever we hit to this hit variable. And we're only going to be hitting things that are on this layer mask, which is everything except for the enemy. So if we hit anything except for the enemy, so when you put the skeleton into your scene, make sure that you're putting it, like if anything is above it, it will hit it. So 50 is like really, really large. So that will be significantly above your enemy. That will be like probably up here. And it's just shooting a ray directly down. And it's not going to hit the skeleton because he's on the enemy layer. The first thing it's going to hit is this plane. Okay. So 50 is probably really high. You could probably get away with just doing 1 here, like 1Y, and using transform down. It will still work. In fact, that's probably a better idea. Let's do that. So this will just, the first thing it will hit will be the plane, and then it will output that to the raycast hit, and that's how we'll be able to know what plane we're on. And then we want to get the values of the plane. So let's first add debug.log, and we're going to do hit.transform.name. We want to make sure we hit the plane. It's really important that the ray hits the plane, otherwise you could get the dimensions of whatever you hit, and then your character could be walking around based on the dimensions of that object, which will be really, really confusing. And then we want to have variables for the max x and the max z. So we'll do, okay, so the max x is going to be the hit.transform.lossy scale divided by 2. Okay, so let me just kind of explain this. So the maximum x, because the plane is directly in the center, right? The middle of this plane, like right here, is 0, 0. So the size of the plane divided by 2 is the max x, and then the min x will be negative that number. So like, let's say this plane is 100 in size, right? Max x would be 50, min x would be negative 50. I hope that's not too confusing. Lossy scale just means that it's using the plane. So like if you have a scale, let's say you take your skeleton, for example, and he's 5 by 5 by 5 on XYZ, right? And you put this into a skeleton container, and this skeleton container is also 5 by 5 by 5. Well, then your skeleton is 25 by 25 by 25 because they multiply together. So the lossy scale is the final result of all of your scales added together. So if you use the local scale of the skeleton container, it would only be 1 by 1 by 1. But if you use the lossy scale, it would be like, if you use the lossy scale of the skeleton, it would be all of the things that are inside of it put together. So it just kind of adds all the scales together instead of just using the local scale. So you need to use the lossy scale. It doesn't affect the plane because my plane is not inside of any other objects. It's just on its own. It's not multiplied by anything else. But you should use lossy scale anyway because that's a better, the better option for this. The reason we're multiplying it by 10 is because planes have a scale of 10 by default. So cubes in the game in Unity are 1 in scale, but planes are 10 times the size. So for example, my scale for my plane is 48.6 and 25, but in actual the units or whatever, like if we were to put a cube here, it would have to be 486 to be the same size. So planes are 10 times the size of regular objects. I don't know why they made it like that. I didn't make it, so don't blame me for it. But basically you have to multiply this by 10 because they're 10 times bigger than normal game objects. So anyway, so min x is just going to be negative max x. And then the same thing for z. Okay, and then we're just going to put found the plane as true. So this will only return true if it finds a plane. If it doesn't find a plane, this will just run indefinitely. I mean, it's not really, you should make sure that it's going to find something, because if this keeps running, it'll probably lag your game or add some type of performance penalty. So make sure that you're actually putting this on a plane that it can find. And you could use the debug log to determine. So if this doesn't spit anything out at all, then you'll know that it's not hitting the plane. But anyway, so after it found the plane, if it's already found the plane, then we want to start the movement method. So what we want to do is we got to create an integer. Hang on. So we're going to have an integer called I, and it's going to be starting at 0. And every frame I is going to get incremented. So I++ just means that I will become I plus 1. Essentially. So on the first frame, I will be 0. The second frame, it'll be 1, 2, 3, 4, etc. So in the else statement, if I, and then we're going to use modulus, random range of 50 to 300 is equal to 0. So modulus basically just means if that number is divisible by the other number. So like, let's say I is 100 and the number is, like, the random range is 100, then it's divisible. If it's 200, it's divisible. If it's 300, etc., right? So as I goes up, it will become, so let's say this was just 50. So when I is 50, 100, 150, 200, so every 50 frames essentially, right? And this is giving it a range. So this will make it really random so because this is how we're going to determine when he changes directions. Is not it's going to be a little bit random, so that he's not just like changing directions at the same exact interval every single time. It's going to be a random period of time before he changes directions. So then we're going to need a method called go new direction. So let's make that right here above this. So we'll do direction. And I need a variable to contain the direction. So direction is just going to be an integer as well. So direction is equal to 0. So 0 is going to be left. 1 can be up, right can be 2, etc. Right? So we're going to do it like that. You could also technically use a string, but then you would have to define like an array or something like that, and it's not worth it. So, okay, so direction is going to be random range of 0 to 4. So random range is actually exclusive. So this higher number is actually going to be 3. So it would be a number between 0 and 3. I don't know why they did this, where this is the top number of random range is not inclusive. So the bottom number is inclusive, so 0 will be the bottom number, but the top number is not inclusive, so it's going to be 3. So there's only 0 to 3 in the range. So if the direction is 0, we're just going to put in a comment here on the right that this is the left, so that we remember if we have to come back and edit this. We need to get the nav mesh agent so we can actually control this. So let's create the start method, and we will create a private nav mesh agent. I guess I didn't need to write private here. Nav mesh agent. And we'll just call this NMA. And then in the start method, we'll do NMA is, oh, it auto completed for us. Perfect. So this is the nav mesh agent that's attached to the skeleton. And we're just going to be using that to move the skeleton. So that's why we're getting, we need to get this in the start method, or we could drag it in, like we could change this to a public variable or serialized field, and we could drag the nav mesh agent into that and use it that way. And that's actually probably better, but we're not going to bother with that right now. So the first thing we want to do is just set the velocity to vector 3.0. This will make him stop instantly. If you don't add this, when he changes directions, he will like curve around. So maybe I'll show you that after. Okay, so let's go through this. So if the direction is 0, which we've determined is going to be left, we're stopping him instantly, so he stops on a dime, because we want the skeleton movement to be really static. He's only going left, up, right, or down. He's not doing any like smooth turning at all, because when we put him in the room, we're going to be putting like blocks and stuff in the room, and we want him to just be going only in straight lines, never in curved lines. The nav mesh agent will walk around anything anyway, but yeah, having him walk in straight lines is way better. So we're setting the destination to be the minimum x plus 35. Now the reason we're adding 35 is so the minimum x is like here, right? So this plane, if we hide these walls, let me hide the walls, hang on. The plane extends past the wall. We don't want him going right up to the wall. We only want him going to about here, right? So that way it's really, really clean. He's not going to be like walking directly into the wall and getting blocked by the wall. He's going to be stopping about here. So that's where about 35 is, about here. Now 35 will probably, like I said, your scale is not going to be this large, so you probably need a much lower number. But just know this is the buffer, because we don't want him walking directly to the edge of the plane. We only want him walking up to a certain point on the plane, and then he'll turn around or whatever. So that's for left. So then we just need to do the same thing for the other 3 directions. I'm going to do 45. So the difference is because my top, if I hide the walls, you'll see it, I guess. But this is going up a little bit higher. Just it ends up being better. You can play with these numbers and work out whatever numbers work for you. Okay, but this is what I needed to do to make it within the boundaries. Like, so again, this is only working on planes. So if you have like a circular shape, like a cylinder or something like that, that your raycast ends up hitting, because it will return any game object, right? We're just checking the scale of the game object. So technically, if you had some other object below it, it could technically get the dimensions, but it will try to walk, like if it's not a square, if it's like a circle or something, we'll try to walk into the corners or whatever. And like the nav mesh agent won't walk, like it won't go through walls or anything like that. So like it's smart. You have to bake the nav mesh surface so it will know where to walk to, but just to prevent anything like that, just only put this on the plane. Okay, so if this range happens, then we just want to call this go new direction method. Okay, and then we want to add something else as well. I'm just going to copy this for my other method because it's too long. I don't want to type it, so I also don't have it memorized. Oh, right, we need to actually have that. So float dist is anime.remaining distance. So basically what this is going to do is if you run out of space, like if he actually makes it to his destination, we don't want him to stop. We want him to just keep walking like all the time. He should always be moving. So if he gets to his destination, which is, we're checking if the destination is not equal to infinity and the path status is path complete and the remaining distance is 0, then he'll go a new direction. This will make him, instead of stopping when he gets to the destination, he'll just immediately start going again, because technically he could reach the destination before this random range happens. So like, let's say this random range doesn't happen for a little bit. Like it could be, like the lower numbers you make these, the more often it will happen. So maybe this doesn't happen for, I don't know, like 30 seconds or something. He's obviously going to be at the wall already. So if he hits the wall or he hits the edge of where he's supposed to go, he'll immediately turn and go a different direction. So if we save this, we should be able to run it now and he should be walking around the room. Let's see. Okay, so it looks like the thing didn't hit the plane. So we're just going to actually move it back up to 50 so that it's above the ground and it goes directly downwards. Oh my goodness. Because I know that this is working. Okay, here we go. All right, so he's walking around the room, but he doesn't have his animation playing. There's an animation for him walking, and we haven't even set up the animator at all yet. So back in the project, we just need to right-click at the bottom and create an animator. An animator controller, sorry. And we can just call this skeleton controller tutorial. And we'll go ahead and click on the skeleton container. And he doesn't have an animator on him either, so we'll just put in an animator here. And then we'll drag the controller onto this, and then we'll drag the avatar from the skeleton onto this. So that's in the drop down. Like if you click on the skeleton model, there's an, as long as you did the thing at the beginning where you create an avatar from the model, you should be there. Let's just make sure there's not an animator on our actual skeleton. And then we need to set up the animator. So if we double click on this skeleton controller tutorial, if we right click here, we can create an empty state. We'll just call this idle/walking. And we can drag the animation for idle walking into the motion section. The first animation you create in an animator controller is the default animation. So that means that he'll be doing this by default. We also want a speed float. And we're just going to change the speed to be multiplied. So if we click on this and we click this little checkbox on the right, it will multiply the speed by this so we can make him walk faster or slower. Let's make the default speed 1. So this way we're able to stop him. Like if he's throwing his bone, we don't want him to continue walking. We want him to be stopped first. So let's see if that actually makes the animation work. Like I said, it will do the default animation, so you don't need to really change anything. So you can already see we got the skeleton walking around. It's pretty cool. Let's see if he makes it to the edges of the walls and stuff. Okay, so he's changing directions too often for my liking. So we need to make the range significantly larger. So he's just like, he's not making it to the edges of the walls because it's running out of time or whatever. So let's change this to like 1000 for now, and let's see if that's any better. Hang on. So the range is still 50 to 1000. So this will make him change directions less often. No, it's not better. So let's go ahead and we'll do debug.log. So what this will do is it will output the information that we have here, and we just want to see what our maxes are. And then we just want to look at this as well. Hang on. So min x plus 35. So that's like from the left plus 35. Okay, let's see what they are. Hang on, let's run this again. 5, -5, 5, and -5. So it must have hit the skeleton container. Oh no, I know what I did wrong. Okay, so you actually have to put layer mask is equal to this squiggly symbol layer mask. So in order for you to use the mask, you have to, like, in order for you to use the everything except for 8, so this will make it only layer 8 that it's hitting. So this will force it to hit layer 8. This does the opposite, where it hits everything except for layer 8. So that's why it's not working. So this should fix it. And then we don't need it to be this big. Let me just change it to maybe 200 by 1000 for right now. And then let's see if that he gets to the actual edges of the level. And I know he does, because in my other script it works. So let's see. Okay, so this is looking really cool. So now we need to make him throw a bone at you. So what we want to do is we want to have a variable for throwing bone. So we could have a Boolean value called throwing bone. And we'll set that to false. And then it's the same kind of deal where if it's within a certain range, we're going to throw the bone. So this is only happening if we're not throwing the bone, then we're doing this stuff. So then we want to have another random. So if I modulus random range of 300 to 600, we ideally want this to be bigger than the range of like walking or whatever and turning, but we want to throw bones quite often. That way it makes it harder. Like, harder games are always funner. So throwing bone will become true. And then we'll do a coroutine for this. So we'll create a coroutine. We'll just make it right here. So I enumerator throw bone. Okay, so then we just need to start this coroutine. So start coroutine throw bone. Oops. Okay, so the first thing we need to do in the animator is actually set the variable that makes him throw the bone. So if we go back into Unity, we haven't even created a thing for this yet. So if we go to the animator, we can create a new state, and this state could be called throwing bone. And in your project, you can copy the attack animation into this. And then if we go to the parameters on the left here, we can add a trigger, and we'll call this attack. And then we'll right click on idle walking and make a transition to throwing bone and one back. And for the transition on the way to throwing bone, we don't want an exit time. So an exit time is like this animation has to finish before this one starts. So we don't want an exit time. And we want to just change this transition duration to 0 seconds. We want it to transition immediately. So he just instantly starts throwing the bone. We don't want like a 0.25 second delay before that starts happening. And then the condition is the attack trigger. And then on the way back from throwing the bone, we don't need any type of condition, but we do have to have this exit time. Change the exit time to 1. We want him to fully finish throwing his bone before he starts walking again. I don't know why. So I think they added this transition duration by default to make it smoother, but I just find that it's kind of annoying. It's not really beneficial at all for... I haven't been using that in any of my animators at all. So now that we have this throwing bone animation, right, and we've added that in there, we can set that trigger in the code. So what we want to do is we want to get the animator. So we want to just do private animator A, and then we can do A is get component animator. Visual Studio is actually really good about getting this information automatically, it looks like. So then in this, we just want to do A dot set trigger attack. And then this will automatically, because it has an exit time and it only leads to one spot, when it's done, it will just automatically go back to walking. You don't have to do anything else for that to work. So okay, so there's 2 more things that we're gonna need before we continue with the videos. The first thing is that we need to get the actual bone itself. So we want to throw a new bone that's completely unrelated to the skeleton container. So we want to drag the bone back into the scene, and we want to make this so that it has some properties as well. So we're going to right click and unpack this. And then we want to add we want to make it 5 by 5 by 5. And let's just move it over here so we can see it. we want to add the material to it. So the same material that we have on the bone that he's carrying in his hand, we want to do that with the material as well. So we're making a prefab for our bone because the bone he's carrying in his hand, he can't, like, that has to stay in his hand, right? So we're going to create a prefab that he's actually going to be able to throw. So let's add a box collider to this. This should automatically be the right dimension. So it should automatically encompass the bone. And then we need a bones. Oh, we don't need the bone script. So if you were putting this into your game, you could add a script to the bone that has collision detection for when you hit your player. But because I don't know the setup of your player and how your player is set up, there's no possible way for me to show you the code that will make it hit your player. I can show you the code that makes it hit my player. So this is my bone attack script. So if the collision is my player's name and I haven't already hit the player, then I call the method that damages my player. But again, like I said, you might not even, like, I don't know how your player is set up, so that's not going to be viable for you probably. So this is the bone pretty much. That's all we really, oh, we need a rigid body as well in order to throw the bone. And you don't need to change any of the settings. You could just leave them the way they are and then just drag the bone back into the bottom. This is creating a prefab. You can rename this to bone attack if you want to, so that you can know the difference between the two, and then just delete this out of your scene. And then what you want to do is, back in the skeleton script tutorial, we want to create a variable to store this. So we will make this a serialized field and private game object bone. And then we want another serialized field for the location of the hand that you want to throw it from. So we'll just say left hand. So after you've made these two variables, you need to go back into Unity, click on your skeleton container, and in the script section, there should be two spots for variables now. So the first one, we need our bone attack to go there because that's what we're going to instantiate when he does the attack. And then the second one is going to be the arm L. This is where it's going to get spawned. You could actually, sorry, you could put the bone in there. The bone is where it's coming from, technically. So that would be fine as well. So then we'll save this, and then we're just going to go over the code to make it throw the actual bone itself. Okay, so in the interest of saving time, I've copied the script, the entire script for the throw bone here. So first thing we're going to do is stop the nav mesh agent and also disable it. If you don't do this, it looks, you can't do the look at. It won't work. It will just mess up if you try to do look at. If the nav mesh is enabled, that's really the only way that you can move the enemy. So if you don't disable this before you do this, it won't work. It won't actually turn and look at the player. So then we're waiting for like 1/10 of a second, and then we're setting the trigger to attack, which is like the animation of him actually winding up and swinging his arm. And then we're waiting another millisecond, and we're going to instantiate this bone at the left hand position, which is where we drag, like the object that we dragged in, we're instantiating at that position, which is the bone that's in his hand. It's not actually the left hand. And the quaternion identity means it's the same rotation that your prefab is already in. So like if you've rotated your prefab inside of like when you like made it or whatever, this will be the rotation. It doesn't matter. The bone is going to be spinning when I throw it anyway. And then we're taking this game object and we're adding force to the forward of this, because this script is attached to the skeleton. So we're adding this to the front of the skeleton. So that's the direction the bone is going to go in. And this number is how fast the bone is going to go. So like the higher the number, the faster. 500 will be significantly too high for your game. Make it like 50 probably for you, depending on what scale you used. And we're going to use force mode impulse. This really makes it go like flying or whatever. Then we're going to destroy the object after 3 seconds, and we're going to return after 0.8 seconds. We're going to change all these things back so that your character will start walking again. So if we save this, it probably will work. Let's just check. Yeah, there it is. So that's pretty much it for the tutorial. Like I said, you can make it hit the you could, like, so in that script, like the bone script that you attach to the player, you could change how the bone rotates and how it's working, and you can change all the numbers around. But this is the basics of how to actually make this character. So I hope you guys enjoyed the video. If you learned anything, make sure you like and subscribe. I also have a Discord server that I've made, so if you have any questions about the game or what's going on in this, or you get stuck on anything, you could join my Discord and ask me questions, and I will help you. Yeah, and I'm usually on my Discord between 9 a.m. to 5 p.m. and you could just join and I'll help you. But like I said, I hope you guys enjoyed the video, and I'll see you in the next one.